Well, welcome to week 5, everyone. Last week we had an overview of the solar system and a close-up view of the planet Earth, and we're now going to be applying that to the other Earth-like bodies in our solar system, as well as our only natural satellite, the Moon. So you're going to be comparing our Moon to the planet Mercury. You'll see that they have a lot in common, but they are not identical. You're also going to learn that we still have a lot to learn about our own moon. For example, where did it come from? Which sounds like a very basic question that we should know, right? Well, as you'll see, there are things about the origin of the moon that we understand pretty well, and there are some things that are, pun intended, still up in the air. And then you're going to look at the planets on either side of us. You're going to be looking at Venus, our twin in terms of size, but not in terms of personality, and our little brother Mars. Good old Mars. Mars, the red planet. Not real size. But the reason why Mars is red is because of its surface composition. But not all of the surface is red. At the north and south poles, we have these whitish areas that are visible from Earth through telescopes, and those are the polar ice caps. And I know what you're thinking, water, yay, I've heard of water on Mars. Well, it's a little bit more complicated than that. When an astronomer says ice, you have to ask them, what kind of ice are you talking about? Don't go ahead and make a snow cone out of any old ice you get from an astronomer. You're going to end up poisoning yourself if you do that, trust me. Astronomers use the term ice to basically describe any sort of frozen material. Now, it could be good old garden variety water ice, and that's great. We love water ice in the solar system. As you might imagine, kind of sets our minds spinning about the possibility of life. And there is water ice on Mars, and we now know that there is some liquid water on Mars. But the polar ice caps also contain a lot of what we call dry ice. Dry ice is frozen carbon dioxide. You might have used it at Halloween if you had a witch's cauldron and you wanted to make some fog, make some smoke come out of it. Right? Certainly wouldn't want to make a snow cone out of frozen carbon dioxide. But Mars has changed over the course of its existence. Mars used to be warmer and wetter. There are many, many examples of features that had to have been formed by flowing water. So at one point, Mars had enough water to have rivers and lakes, and possibly, and this is still being debated, perhaps even something that would qualify as an ocean or a sea. So where did Mars's water go? That's something that you're going to be learning about this week. Okay? You're also going to be learning about how Venus, even though it's about the same size as the Earth and has about the same composition, and yes, it's a little bit closer to the sun, but why did it turn out so wrong? Venus, for all of its similarities to the Earth, is probably the nastiest place in the solar system. It's hotter than Mercury, which is the closest planet to the sun. So you're going to actually go back to the discussion of the greenhouse effect from last week, and you're going to be applying that to Venus and Mars. And what lessons does that tell us about the future of planet Earth? And in describing the other bodies in our solar system, such as the Moon and Mercury, Venus, and Mars, we really have to pay credit to the great people at NASA and the European Space Agency and other space agencies around the world who continue to send up unmanned probes to orbit, fly by, land, or rove around those bodies and kind of get the lay of the land. All of these unmanned probes, no matter what style they are, they take pictures, they make measurements. And really what we know about these other worlds is dependent on these probes. So as you learn about the various properties of these bodies this week, why don't you take the time to think about what an awesome job it would be to work for NASA and to actually be the first person to look through the eyes of a rover at the surface of an alien world.